All right. Now we should be live. I'm just gonna share. There we go. Okay. Still got a little bit of the cold, but hopefully it will be better tomorrow. Right, so yeah, last stream we did a bunch of stuff here. Expanded the monster AI, so that went very well. It's very basic though, but at least it's working. I'm thinking about what to do next. Do I want to fix this projectile? So I got a couple of options here. We can fix this. And also fix like the player animations, because I'm right in the middle of like redoing those basically. And I'm gonna stick to sort of making the animations more less keyframey. Like well, mostly because, well, it's sort of an aesthetic, isn't it? Sort of low frame rate, and then also, yeah, it really helps with productivity, so you don't have to do as much, as many frames. And yeah, I'm in the middle of redoing the player animation because, well, I was never actually happy with the player sprite, so I'm gonna redo that. It's a little bit like this. How you say it? Like, you can see the original player anime has like these black ink outlines, while the new one doesn't actually have that. So, and that goes against a little bit how the monster looks as well. So if I'm gonna keep that, I want to keep that. I want to have that for the monster as well. So, but yeah, that's like a very minor. Well, it's a minor detail, I guess, but it's like a very minor thing because it's very easy to just fix that. Actually, but yeah, and the whole point also is to try different things to see what works, I guess. But let's actually try and do this. Another thing that I want to add is also maybe we can get to physics groups, because that would really solve a lot of issues and enable us to do a lot more things. So yeah, so physics collision groups. All right, and Yeah, let's start with this one. So I need to figure out how to actually implement this. I mean, we could intersect, like check for intersections each frame, I guess, for each rock. There's not gonna be that many rocks on screen at once, so it's probably not that big of a deal. And checking for intersections shouldn't be that costly since we already have the Q3 and everything, I think. And yeah, so we're gonna check that they are touching the ground. We could actually have a new component for that, like destroy on touching, like static, maybe. So we do have this destroy on touch, and I guess this is now hard coded to actually look at the player, but we could also make this like generic. But then how would you get the view out from it is the question. Not sure if that's possible. So my thought was that if you make this generic, you can pass in a bunch of types like that you want to check against, and that way you can check against the player or static bodies or anything else that could destroy this component or this entity. But I don't think you can actually then create a view for that, because that would become like a unique type, I think, and then you need to go through each type. I don't think you can go through like generic types in this ECS. You have to like well, I guess maybe one thing you could do, if you have, maybe if you could have some sort of container. No. Because the type, yeah. So one thing is the type cannot be stored in comtime, or sorry, in runtime anyway. So I think when we do this update, we can't really, we have to know the types in comtime anyway. I mean, I think for now we could say we have some sort of type here, destroy on touch type, and this is an enum, and we say, well, we destroy on player or ground. So that's the two kind of types that you can have on destroy on touch. And then we do this and we say if, well, I guess we could get the player body whatever anyway here. So here we check, so if we need to get this as well. So here we can say if the type is player and we intersect with the player, then we destroy. Else if dot type is, I guess we can do a switch here. Always switch. Player. Then we do this. Otherwise we have ground. So then we have to search for all intersections and find something that is, I guess, static. So we would need the physics system as well. And yeah, find intersections. I guess we could use body here because we have the body there. And yeah, then we can also get the allocator. Well, defer allocator the intersections. All right. Now we'll loop through the intersections and I think what we'll do is we just check if the entry is static, then we return. Wait, no, not return. We do break, and we also append it there. Okay. So now we have two different types of destroy on touch, player and ground. Okay. And let's check here. So the rock has, oh, I guess this has like both types. So maybe this should be like an array. Maybe. Or we can just say all. Actually, if it's all, we want to do both of these. And yeah, so let's break these out into functions. So we're gonna check player collision. I guess it's a bool, and it's just gonna be this. So we'll have body and player body. Okay. Then we also need check ground collision. And we need dot body. We'll return this whole thing. Yeah, we need the allocator as well. So this will return true. We return false down here. We need the physics system as well. I guess it's a pointer. All right. Now let's go back up here. So here we'll just say if check ground collision, and we need what? Allocator physics system dot body. Then we do that, and we don't break. Here we check player. And here we do if or ground. Then we do that. Okay. What's happening here? Oh, this type is all. This one is a pointer, so let's do get const. Okay, so now the rock should let's see, I need to enable my controller here. There we go. Okay, so the rock should disappear. Oh, it disappears immediately. Okay. So there's probably something happening here. So it says static. I mean, it's colliding with a monster, but the monster isn't static, right? Oh, hey, Stone Chat. Sorry, I posted the SIG Discord. Oh, nice. Welcome. How are you doing? We are trying to build this game here, so something is not working with this. Wait, this should be ore. Yes, it's ore. And okay, I'm just gonna check. I'm pretty sure the monster is not static. No, it's not. Okay. And this body, yeah, we're checking the AABB. That should be like the hitbox. So it shouldn't be hitting the ground. Is my point there. Are you using Raylib for rendering? Yes, I am. It's quite nice actually. Really easy to get started using Raylib. And you can do a lot of things with it. It has some very nice like features. And it's very easy to use. I was thinking about trying to make a game in SIG, just started playing around with it recently. Oh, nice. What kind of game are you thinking about? I've seen a lot of people like talk about a bunch of different engines and libraries and stuff, but like SDL and Vulkan and what's it called? MACH. But yeah, I'm just using Raylib and an ECS library as well. Did you ever play the Game Boy game Mega Man Battle Network? Basically a clone of that. I have not played it, but I think... Is it like a tactical game? Yeah. I've only tried the Raylib thing. It works very well for what I'm doing here, so I'm gonna stick with that. And until there's like there's some sort of issue that comes up that we need to like replace the whole thing, I'm not gonna change it. It's on a grid, but it's more action focused. Okay. Interesting. So is it real time or is it turn-based? Because I've seen like pictures of it. It looks interesting, but I never actually played any of those games. The Battle Network games. I'm just gonna check if we get here. There's rounds. It's real time, but each round you get a set of chips, which are attack, defense. Okay. Deck builder. It's still competitive. Oh, okay. So it's like multiplayer. That's cool. That sounds interesting. It wasn't really what I thought it was. So that's cool. Wait. Okay, so we do get collision with static here. I don't know why we do that. I want to also print out the ABB. I believe there is a format for this, yes. I wonder if you can do this to print it here. Yeah, there's a 1v1 mode. Okay, nice. Yeah, maybe I'll try it sometime. Sounds fun. I have like periods where I like tactical games and then go back to real time and back and forth. This is top left. This is bottom right. Well, I wanna see the size, so let's print that. Have you programmed much otherwise, or? $40 by $40, so that's correct. How's the metadata leaks? Sort of. I'm a data scientist mostly, except spent a year doing the game development. Okay, nice. So what are you most passionate about? I get leaving, so I'm trying to code my free time and get another game dev job. Oh, so did you do game development first and then you became a data scientist, or? Yeah, I've been a web developer for like 10 years. And before that I was self-taught in C++, and now, but I always wanted to make games, so this is like my calling here. Okay, data scientist, then game dev, and then back to data science. Oh, okay, I see. Yeah, that's, yeah, I'm trying to pursue what I think is fun now, so I believe if you have the possibility of doing that, that should be, I mean, a good thing to aim for. So did you work on in a yeah, for the money? Yeah, I mean it's the same here basically. I'm trying to get this working now, so I'm trying to. The dream would be to be able to make games and have that as a job, because that's what I actually want to do. I don't want to be in web development, even though I think programming in general is fun. But yes. Let's see. Yeah, I don't know why this collides. What is it colliding with, though, is the question. More creative, yeah. Oh yeah, I was gonna ask, did you work at the game company or did you work like, where did you try to do? Oh yeah, a game dev job, yeah. So you worked for a company now. So I don't know. I think I would rather like work on my own ideas and stuff like that. I don't know. Contract studio, okay. But I guess it's interesting either way. I mean, I'm sure you learn a lot, especially working with others and stuff within the field. Okay, I think I need to. I want to check what is the dimensions of this other entity here. ABV size. Okay, yeah. Have a nice day. Thanks for chatting a bit. See ya. Okay, let's see. Wait, we're looking for collision. Okay. Whoa, what's this? Oh, it's the tile map, I think. Okay. Yeah, that makes sense. So how would we know it's a ground tile? Maybe we should create a component for that. That would be an easy way out. And it will sort of abuse the fact that we're using ECS as well. Let's see, the ground. I think ground is basically just an entity with a body here, yeah. So yeah, let's just make a ground component. and we have to have some sort of data in there so the ECS system is happy. And let's bring this in here. No, entity and then ground. Okay. Okay, so now all the tiles should share this ground component now. So if we go back to destroy on touch, we can now check, is it static, and does it have, wait, we need a registry as well. Does it have a ground component? And we need to bring this in here. Now what's this? Whoops. Oh yeah, we need a registry here and here. All right. There we go. And now it gets deleted once it touches the ground. So we should probably also have it deleted when it's like, if it goes beyond the boundary as well. Okay, it was almost fun. Oh, excuse me. I'm just gonna pour some drink here. All right. Okay, so that works. I'm just gonna go here. We're gonna take this off. Destroy on out of bounds, I guess. And well, that's not ticked, so all right. are we gonna tackle this now? I need to figure out a way to implement it. So maybe we could start with like some sort of naive approach where, I mean, you simply check collisions for everything, but then you only resolve collisions and that means that the collisions are like physical things happening that pushes things around, but you only do it for things that are in the same group. I think that's the idea. So you would go through each group and check if any of those has any collisions. Or you go through each collision and check if both entities are in the same group, or if they share a group. Then you resolve the collision. So then the question also is like, how do you define a group? I mean, it's basically just a list of entities. It could be a hash map, maybe. So we'll go into the physics or the game engineer and we go to, I guess, physics, collision, and I guess you could do like, yeah, if you do a check first to see, well, since the checks happens in the quad tree, I think it might, maybe you could build a quad tree for each group then. Actually, no, maybe that's not a very good idea. Well, I mean, it depends on how your collisions. Like, let's say if the player wants to check, if we want to check the player against everything, basically, then everything needs to be in the same group. So that doesn't make sense. It's just the player that needs to be checked against everything else. Everything else does not need to be checked against everything else. So maybe that's a bad idea. So I think, I mean, one way to do it is to define groups, but then the actual collision checks are done. Then you set up, like, you say, okay, player is gonna be checked against this group and this group and this group. And the rocks, for example, the rock is gonna be checked against the ground group, let's say. And the monsters are only gonna be checked against the ground group. Yeah. So you define the groups and then you add the entities into those groups. Let's do that. So let's define a group. And I mean, this would technically, this is an entity group, I guess. And let's grab standard library. Once. What's this? An object that executes the function once. Okay. Anyway, I wanted to check string hash map or string array hash map. So an array hash map with strings as keys. Well, actually, it's not. Okay. I wonder if there's an auto array hash map. Yes. Okay. Auto array hash map. Default hash and equal functions. So it's a hash map, but it has order, I think. Hash table of keys and values, each stored sequentially. Yes. So you can loop through them, I think. Insertion order is preserved. See array hash map unmanaged for managed. Yeah. Okay. And if you do auto array hash map, then you can provide like any type. When I was thinking, if you provide the ECS entity here, so the K would be this. And the value is nothing, actually. I mean, basically what I want is a set. Is there such a thing? But what I was thinking about hash maps was because you can have the key as this, and then it's like indexed, or it might be indexed, maybe it's not actually, I don't know. Yeah, here's the... Yeah, it is indexed. Okay. Okay. Where's the index though? Here? Okay. Yeah. So the point is that it's a quick lookup. But we don't really need to have a value to be associated with it. But I guess we could just add bool. Or maybe, can you have void here? Maybe not. Let's just do bool. So it's just gonna be a list of entities, and then the idea is we want to have now a sort of link between entities and a list of groups. So you would have something like entity to entity groups. So this is the entity here that we're talking about, and then the groups that it's gonna be colliding with. So this is like one entity though. Maybe in the background we actually, if you want to just take one entity and say this should be able to collide with all this, like the player for example, then it actually creates a single group or a group with that single entity in it first, and then reuses that group whenever you want to do that. So you actually, what we actually want is entity group to entity groups, and then we have the entity group, which is a pointer to an entity group, and then we have the entity groups, which is a list of, I guess this could be like an array list of entity groups, pointers to those. So that way we can store each group's relationship to the other groups. So if you have one of these in that, let's say we have the collision container or whatever, and we have collision enabled groups or whatever, collisions enabled for, and this would be I guess this could be a list of entity group to entity groups. So maybe something like this. I was just thinking how you would search in this for whatever entity. Like, let's say, Okay, so what scenarios are we gonna looking for here? So when checking for collisions, or rather when resolving collisions, I think when checking for collisions we're just gonna do one quad tree and all intersections will be reported. But then when actually looking, if you want to see, so the loop will be checking one entity against one other entity. So you would have to go through and see which groups does the entity belong to, perhaps. So, and it could be a two-way thing as well. So you have two entities that are colliding, and the one entity could be related to the other entity through this relationship here, but the other one could also be related to the first one. And as long as one of them is related to the other, then we resolve the collision. So we probably want to index per entity then, which groups the entity is actually checked against. So what we could, or actually we could like index for each entity, we can index all other entities that it's supposed to be. That's gonna be a huge memory hit though, I think. Potentially. Maybe we could do some smart optimization there. Wait, I'm thinking way too much on optimization now. I said I was going to make a very naive approach, and then I'm starting to think about all of these issues. So let's just build something that works and then think about how we can optimize it, I guess. But I want to do something like this, and I think instead of doing entity groups, we just want collisions enabled for, so this would be not an array list, this would be an array hash map from entities to a list of groups. Or a list of entities. Well, let's do a list of groups, because then it's way easier to, then we don't have to update this list every time. We just have to update the list if we want to remove a group or add a group into this specific entity here. And if you want to associate one group with another group, you can go through each entity in the group and change that here. So that should be good for that. And that's really nice as well, because now we can look up the entity. If we want to see, okay, does entity A need to be resolved against entity B? Then we just check entity A. We can get it from this list and check all the groups if entity B is in any of those groups, and those are also indexed, so it should be like fast lookups. Otherwise we check entity B and get those groups, and we check there as well. So we would have a function that's like is collision enabled for, and then you would have the entity, you would have let's actually do this. Let's make this a type. So this would be collision enabled, or I don't know a good name for this, but let's put this in here, and I guess this would be put in here. And then you would say, is collision enabled for this some entity and the other entity. So entity A, entity B. All right. So it's true if entity A has enabled against entity B, or entity B has enabled against entity A. It's like if only one of them is enabled, then that should resolve the collision, right? So well, this would be a bool, first of all, and we will return, well, let's say if entity A, so we would look at the groups of A, so this would be self collision enabled for get entity A. And it might not even exist, so if we have it, we get it here, and we say for items we get an entity group here. I guess we want to do a get and check if it's null. Contains, there we go. Contains, if it contains entity B. So if it contains entity B, then we return true. Otherwise we just continue. If we have group A, we look at all the items. If there's some containing entity B, we return true. Then we do the same thing for groups B. Now it's entity B, and now we check for containing entity A. Okay. And I guess we want to store the groups as well. Or are the groups gonna be like loose things that just exist out in the wild? No. I think the groups are actually something. Yeah, I think the groups should be in a like a string hash map. And this would be the value. So the value is entity group. Yeah, so we keep the groups in here, and if you want to access a group, you have to know the string key to get it. And if you want to create a new group, you have to provide a unique key to store it. But then it's stored here. So, and the reason for that is, well, let's say you want to destroy a group, then you want to invalidate it here as well. I mean, I guess, yeah, because then this pointer becomes like invalid. So yeah, it makes more sense to have it like this. And then could have a function then that says enable collision for, and then you have this, and you have an entity, and then you have a group, and this could be a group or just a key, I guess. Maybe that's better. Group key. So then you don't have to fetch the group every time. Yeah. Getting distracted by the errors. So now we can grab the group. Well, actually, we need a pointer. And if the group doesn't exist, well, if it does exist, then we also want to grab collisions enabled for. So I think it's like get or put. Group key. No, this key is entity. And what is the error that can happen here? Catch error. There is no error here. Or? This error is catched or caught. Oh, here. Return error. Okay. So it's this error. Isn't this just out of memory error? We got these as well. Find bit index. Okay, whatever. I'm just gonna catch unreachable here, I think. Seems like it's either gonna be like out of memory error. I'm not sure what else it could be. But let's see. What do we do here? So okay, I just lost my train of thought here. Yeah, so now we get this one. Let's see what's in here. So we got the value pointer, and if we found something, then it means it's initialized. If we didn't find, then it means it's like a brand new thing that we need to populate as well. So we need to assign this to whatever this is here. It's array list entity group init allocator, and let's pass in an allocator as well. Unused capture. Okay. Yeah, I'm getting distracted by all the errors and stuff that's popping up. So now we've got this value populated, yes. And then we want to say append. Wait, but the group might actually already exist. So let's first check if contains index of scalar element. I'm surprised if there is no function that actually just returns a bool to check if a scalar is in the thing. I mean, contains at least may be the thing we want, I guess. Okay. Let's check contains. It tells true the haze that contains expected count of one or more needles. Right. So this would be entity groups like this. The slice is items, and the value, wait, no, the expected count is 1, and the needle is group. Okay, so if it is there, okay, actually I would rather use index of here because I don't need to deal with this list at the end. So let's remove this, have the G there, and we return a nullable. So if we have this thing, we want to check if it is not equal to null, or if it's equal to null, then it means we need to add it. So append, wait, add, okay, append group there. Okay. So we want to enable collisions for one entity against a group. And so we get the group. If the group exists, we do some stuff. I think if the group doesn't exist, we want to log, I guess, a warning maybe. Group not found. Group key. If it exists, we grab the collision enabled for group list here, and if we found, if it was populated, wait, no, if it was not populated, we populate it here, and then and now in this case, in this position, we have populated it always, and then we check the items for the entity group, and then if that doesn't exist, we append it. Otherwise, it's already in there. Okay. Another thing you could add is also enabling for another group. Enable collisions for a group. And then, so I guess group A and group B key. And then we have group A and group B. I guess this is maybe. Well, actually, if we don't find group A, we want to log group not found and return. And then we do the same thing here. Now this is something that I found really nice with SIG. This is really nice because then you get this one group A, which is a group. If it's not found here, we do something else and we return. And this is group B key. Because then you don't have to define a separate constant for this result and then check if it's null and then do something or do something else. So actually, up here we can now we can say we can do the same thing here. We can say group not found and then return instead of doing all this. So now we can get rid of this, and we can also say group here and here as well. So that's, I think, a lot nicer. You handle the error immediately as well, which is really nice. Okay, well, at least syntactically here in how it's like located in the code. Okay, and then what are we doing? So I think then we have to go through group A. But now we don't get LSP for it. Okay, that's the downside, I guess. So what type was this? This was entity groups. And those had entities, which has, I think this has just items, right? Or maybe not. Values. Okay, so you can say values, or actually I want keys in this case. For each one of those I want to do enable collisions for entity with the group B key. So then we don't actually need to look for group B. However, it would be nice. Whatever. Yeah, that should work. All right. Okay. So now I think this will suffice in a way to define these groups, and we can also now check if the collisions should be enabled for that specific group. And yeah, whenever we create an entity now, we need to add it to one of these groups in order to, well, actually that's also a thing. Like if we enable, for example, we enable one group to another group, We should also then if we add an entity to a group which already has collisions enabled for other groups, that entity should also get those enabled. So when we do this, but the thing is we don't really have that stored anywhere. We only have entities to groups and not entity groups to other entity groups. We could, yeah, because that would be a nice way to fix it. I guess you could do this. You could say collisions enabled for groups. And we do the same thing here. We have an auto hash map. We have, but now the key is actually a string. So actually this is a string hash map. And the value is this. Okay. And or I mean it could actually be just the string. Wait. Now we don't have to do this. So we have the pointer. I guess the pointer is fine. And when we enable for group, we want to enable there, but we also want to do the same thing here, sort of doing this part, but for the other thing. So this would be groups. We get or put the group A key. If we didn't find the existing, we create an array list of entity groups. So that's the same thing. Then if we, this should really be a set here, but I'm not sure if that exists in SIG. Like it should be a list that only has unique items. But anyway. And then we check, do we already have this group? So I guess we do want to get group B as well. In that case. Group B. And that's nice also because then we do an early check. Okay, does group B even exist? If not, then we don't need to do all of this. And so this would be group B. And this would be group B. Okay. And now we can add functions for adding add to group. Self is collisions enabled for. We have the entity. And we have the group key. And so if we add something to the group, all the groups will be updated, but we also can now do, we can enable collisions for this entity as well. So yeah, so we grab this here, and I mean, I guess maybe if it doesn't exist, we want to create it. I think we want to have a specific thing for that though. Create group, group key, and put group key. What is it? Put or no? Fetch put, no? What does that do? No. I want to get or put group key. And then if we found I'm just gonna log a warning there. Group already created. Group key. Okay. So first you create the group, and then you can start to add things to the group. And we will okay. Now when you add something to the group, we want to we want to add the thing to the group first of all. So let's get that group. Group key. If it doesn't exist, it's gonna be an error. So log error, group not found, group key, return. Right. So now we get the group, and we also want to then and the group is just, it's an entity group, so we need the entities, and I use put there. I guess we could do get or put. And then this would be entity. And if found existing, then we log a warning. Entity already added to group. Okay, Right, so now we have that in the group. Then we want to go through all of the groups that it's like enabled for. And this would be, I mean, or else we just return, for then there's nothing to do basically. If we get it, then we're gonna go through all of those groups and call enable actually we want to do keys. Wait. Oh. So maybe this should be keys instead. But now this is not the same, so yeah, the equality check here is a bit more evolved now. Let's see. Get key pointer. Let's actually grab the pointer out of there, because we could use that instead. So if these are pointers to that, then we can actually still check like this, but now these are these things, and this would be pointer, and then we append the pointer instead there. Okay. So this, yeah, so now this is a pointer, yeah. So now we do this, and this would be this. allocator as well. Oh, and now group B is not needed anymore, so let's get rid of that. Well, actually, let's grab the key like this instead. There we go. So we still get the early cancellation if it doesn't exist. Okay. Right. So now we should have a way to create groups, add entities to groups, have the collision enabled for that group or for that entity towards any groups that has enabled collisions for that group. So we don't have a way of removing the groups right now, but maybe that will come in the future. Okay, so what remains now is to incorporate this in. We don't need this one. We need to incorporate this into the physics system. So let's go there and we'll just import it. Whatever it was called. Collision, no, groups. Wait. Collision and then group. So collision enabled for. Okay. And then we need to store this. I guess we could call this like collision groups. And let's add this here. Oh yeah. Now let's make an init function as well. So let's grab an allocator. Let's just copy this like this. Oops. That. And then this should be equal. Init. Okay. And so we do .init allocator. Great. Let's also add a deinitialize as well. So this thing needs to be deinitialized, so let's add this here as well. And we need an init function as well. group, return entity group, entities equal to this thing, init allocator, okay. So we need to loop through oh, it's just a hash map. So let's grab this iterator and group. We do the initialize. And then we deinitialize the whole thing. Alright. Then we do collisions enable for deinitialize. And this is just a shallow, I guess. No, we need to deinitialize these as well. So we have to go through that as well. So enable for. This one has value, so we can go through them there. And we'll deinitialize it like this. And we'll do the same thing for this one. Okay. That should have taken care of all of that. Yes. Now, also, are we never actually calling init on entity group? So when we create a group, oh, if we found, okay, yeah. So if we didn't find existing, we actually need to now populate this. So this would be entity group dot init allocator. So we need an allocator as well, of course. There. And let's just make sure that we don't get some weird errors somewhere. Get or put. There we just get, there's a get. There's a get or put. So let's do catch unreachable there. Append. All right. Okay. So yes, now we have this. Now we can call also here collision groups dot initialize. Okay. So now let's go to the resolve collisions. And resolve collision. Oh, this is okay. So in here we need to check now. I mean, we can simply do if collision groups is collision enabled for body A dot key and body B dot key. Then we resolve it. All right. This needs to be like that. Let's do that. This one turn false, I guess. Okay, so now if we run this example here, all the resolutions should not work now. We should just move through everything. Yeah. So right, here's the scene. Add rectangle. Yeah. So the rectangle here, so now we do this, we create a rigid body. Okay. If so, when we create a rigid body here, we also want to add this to a group. So we'll add, yeah, collision groups, add to group. And the entity is what? E. The key is gonna be rectangles, I guess. Or collisionites. And let's do the same for circles. Okay. And the player as well. Okay, and now we need to add the group itself. I guess we could do this here. Create group, collision lights. Okay. And then, oh, and also I want to enable the collisions. collisionites and collisionites. So they're gonna be able to, so everything is colliding with everything else. Oh, got an issue. Expected type, this found const. So I think we need to get the pointer there. Okay. And now it collides. Okay, nice. Okay, so I mean the basic principle works. I'm not sure about the FPS there. Let's actually test this. Let's go to the physics system and we'll check if we remove this check here. How much FPS do we get? We got like 55, 50, around 50 FPS. Yeah, it's the same. Oh, but now we have a lot more bodies as well. So it does disable. Well, I mean, it does slow it down a lot. Obviously. Because this demo, it spawns as much rectangles as it can before the FPS drops below like 50 FPS. So, yeah. So now when we load this up, we don't see as many rectangles, but I think it should be fine. Okay. Great. So now we actually have that. I mean, I guess we could test as well. We could test. Let's go to main again. And I want to test. So what I want to do is the player is going to be so let's do the player in its own group. The player. So we'll create 3 groups. We'll create the player group. We'll create the rectangles and the circles. Then we want the player to collide with the rectangles. And we want the rectangles to collide with the circles. So now the player is not colliding with the circles, but the rectangles is colliding with the circles. Okay. So now this one is a rectangle. Oops. Rectangles. And this should be circles. And I want to do here, if we get a random number. We want to do circle instead. Or we'll do it else. Position radius, yeah, that should be. Oh, well, this is not a radius. Yeah. Okay. So now we should have circles and rectangles. I'm just gonna check the circle. Let's increase like the radius thing a bit because they are a bit small. Yeah. Let's do 10 plus 2. Otherwise known as 12. Wait. No. Let's do 10 plus 5. Okay, there we go. I can see the player is colliding with the rectangles. However, they seem to be very heavy. And let's try and collide with a circle. We're not colliding with the circle, okay? Let's try and push this rectangle. It takes some time here because it's like, I don't know, it's super heavy it seems. Let's see if we can change that. Let's see if we can increase the density here. The density is water. Oh, it's osmium. Okay, let's do water for those. Then yeah. So that was like 20 times more density. Okay, we got some rectangles that are close down here. Okay, there we go. Now we can push them way more. Yeah, and there you go. The rectangles get stuck on the circles now. Okay, cool. So it actually works. That's nice. Yeah. So I will add this physics collision groups. Okay. Let's go back here and we'll do this. And if we start the game now, everything should fall between the tiles, because we have collision groups now and nothing is set up for that. Yeah. So now we need to set that up. So let's go to our initial scene. Initial load. We need the physics system. So let's do I was thinking of how to store the keys. I'm just gonna have them as strings for now. So gravity. Let's do collision groups, and we'll add a group. Well, no, we'll create a group. And the group is called, well, let's have a group called player. And then we'll have a group called ground or tiles or whatever. And I think we want a group called monsters. And perhaps, no, that should be it. This is the only thing that is like concerned with collision resolving, meaning like physics simulation collision. Yeah. So we have these three groups, and the player, of course, is gonna be in the player group. Collision group, add to group, and this is in the player. The group key is player. All right. And what else? We have the monster. And we'll do monsters. And then this one is cleared. Alright. And then we also have the tiles. And that happens in this one. And this is, I think it was called ground. Okay. And that should actually be it for that. So now we should no longer collide with the monsters. And the monsters should not collide with themselves. Oh, well, it didn't work, so... Oh yeah, we haven't enabled the collisions yet. Oh, and actually, we need to implement deleting the entities as well, because we have scene transitions and then we just wipe all entities. So we actually need to implement removal of the groups and... well, maybe not the groups, but we want to remove the entities from the groups. That should actually not be that difficult to implement, though. But we'll test this first and then we'll fix that later. So we have our initial load, init physics system. So we have these groups created. Then we're gonna set up which collisions are enabled. So we want to enable collisions for group. So the first one is player against the ground. And then the monsters against the ground. And that's it. Okay. Now it works. Nice. And now we should be able to just go straight through this monster here. There we go. Nice. And let's spawn a couple of other monsters and make them move toward each other. And they should no longer like, yeah, so now they are moving into each other instead of being like pushing on each other. Okay, nice. Yeah, I mean, that went way smoother than I thought. I thought this was gonna be super hard. I mean, it wasn't easy, but... And it's like, it's probably not that... I mean, it could be optimized more. But it doesn't really need to be optimized more for now. We'll see if once we add more stuff happening in the game, if we need to optimize it more. Let's... Oh yeah, and the scene transition. So if we go back and forth now, it's probably... It's gonna have a bunch of entities that are like invalid now. So... Maybe... okay, so let's go to the game engine again. And we'll go to collision group. And we'll implement a function remove from group. I don't think we need the allocator. Entity and the group key. Okay. We grab the group. And then we say if the entities, yeah, then we just remove that. What is that function then called? Swap remove maybe. So swap remove key, yeah. What is this? Adapted? Okay. So yeah. So we'll do entities dot swap remove key. And this will be no, it's not group key, it's entity, of course. Did that have an error? No, just a bool. Okay. So now we that should be it for the group. Now we should also remove this one. So we're gonna get entity, or else actually we just return. I mean, it should exist, I guess, but if it doesn't, then whatever. Now this one is an array, I believe. So no, wait. We just remove the entry. Yeah. There we go. So we grab the group that it's in, we remove that from that group, and we also remove it from this index here. Okay. So now we have that. Let's try calling this just so that we don't get any weird compiler errors that we don't want to have. So we'll do remove from group as well. We don't need allocator. Of course we do get errors here, so these return bool, and that's why I wanted to test it out, so we don't have to go through the whole thing of pushing this up again. Okay. Added function to remove an entity from a collision group. Nice. Okay, let's go back here and grab this again. Right, so now we have the ability to remove entities from the group. So when we transition, we want to remove everyone from their respective groups. So actually, right, actually, now that I think about it, we probably want to have just remove this entity from everything. From all groups. From all groups. So then we need to like go through each of those. Wait. Yes. And then while we have a group, we do this. If it exists. If it doesn't exist, Okay. So if it doesn't exist, this just returns false and it's fine. Okay. And this doesn't care if it's mutable or not. We get a value iterator. This needs to be pointed there. Okay, that should work. I'm just gonna again wait, call it and see. No, no errors. Okay, nice. Added function to remove entity from all collision groups. And oh, yeah. So we could actually just add that. We could bake that into remove body. This one, because this destroys the entity anyway, so we should probably do it here as well. Collision groups, remove from all groups entity, and that way we actually don't need to do anything else in the game now. This is handled here. So yeah, so entities are automatically removed from collision groups when their rigid body is removed. Okay. Now we can store this again. And yeah. Okay. So now we should have no, at least less fear when transitioning. I guess we could double check in the memory and all that to make sure that it's empty, and but I'm just gonna not care. Okay. Nice. Now we can just easily skip through all of these monsters. Maybe we should add like touch damage on the monsters to make it a little bit more challenging. Now we can just straight go through everything. Probably would be a good idea. I mean, and now it's pretty easy because we could just add here. Yeah, we'll just add damage on touch here. Hey DC, that looks cool, man. Thanks. Yeah. Nice to hear that. Yeah, I'm trying to make a cool game, so let's hope it's gonna be fun to play. I'm gonna try my best. So now we can add this damage on touch. Yeah. So we need to import that. don't touch there. And yeah. And that should be it, actually. So now we should, yeah, or wait, no, it's actually not it. Interesting. So why is that? This one, yeah, it checks against the player. Okay, let's open up these. Oh. Yeah, it seems to be, it seems to work, I think. Brian Phillip, you made a lot of progress since yesterday. Oh, yeah. Hello. Yes, I've been working a lot now. I had a bit of time yesterday and today, so I've been advancing. It's been gone pretty smooth, actually. We hit like a really annoying allocation issues, well, a lot of those, and but now we are on track, I guess you could say, or there's no track really to go to, but yeah. But why is it feels like he's not being damaged immediately, or yeah. Oh, maybe it's because of the shield. Right. It's staring me right in the face here. Those alloc problems are worse than saying once they get the compiler errors to be better, they may get easier in the future. Yeah. I mean, yeah. Sometimes it feels like the fault is mine, and because of how like manual memory managers works and pointers and all that. But the issue is that it's really hard to debug sometimes, and it's hard to like find where the issues are. Especially, yeah, I mean, issues that come creeping up from below from long ago, where you did something stupid and you didn't realize at the time, and then you need to try and find the issues, and you're perplexed on how to do it. But yeah, perseverance is key as well, but it's yeah, it takes a lot of energy sometimes. So actually we could just add here does like is shield block shield blocks, I don't know what to call it. Let's set that to nothing and we will define it. shield blocks is false. And here shield blocks is true. Okay. Have you ever played MapleStory? This game reminds me. Oh, yes, a very long time ago. I think when it was like kind of new, I played it a little bit. When did it came out, actually? Well, I was playing World of Warcraft when that came out, and I remember maybe around that time, maybe I was playing it. I don't remember. It was so long ago. Okay, there we go. Now we got some damage on touch there. So that makes it a little bit more challenging. So you can't just like, well, you can sort of jump through it here, but well, there I got sort of stun locked and killed there. Okay. Maybe the invisibility frames should be longer. Is it the graphics, or what is it that that reminds you of MapleStory? Because I think this is gonna be like more. Yeah, I mean, it's gonna be a Metroidvania, so. Okay, now this is weird. It should be damaged now. Wait, was that an actual crash? Index out of bounds. What? Yeah, the graphics style, okay. 2D side scrolling shape of the slimes. Ah, yeah. Typical monster type. It's like it's pretty easy to, I guess, make. That's why I made it like my first sort of monster. It sort of fits in the lore, but I think I'm gonna change it a little bit, like the design. It's supposed to be sort of like a clay based, like magical, like clay elemental, let's say, to make it like a very easy comparison. And yeah, I'm still learning, like doing this pixel graphics stuff as well, so it's fun to do, to learn. It's but I'm not gonna I'm actually it's fun to make the pixel art, but I'm not gonna like sit and get like the perfect graphics for this game. I just want to be like stay productive, and the graphics is not like the highest priority. It's gonna be like the gameplay. Okay, now we get this crash. So there was another weird crash happening here. Index out of bounds. Entries is entry in tree. I mean, maybe that's related as well. Okay, yeah. So if you stand in here, Do you actually still... You should still take damage. Why am I not taking damage now? Is it because I'm not moving? That's strange. Okay, so why would that be the case? This is just a simple rectangle collision check. Oh, right. I'm actually not checking the shield blocks here. So this whole thing needs to depend on whatever it was. But yeah. This game is gonna be more like it's gonna be like you're playing sort of a small humanoid creature, so everything is like is supposed to be well, you're playing sort of a miniature, so everything is like scaled up. So that's why I think it's like also a little bit interesting, because I don't see many games doing that sort of thing, at least not for side scrollers. I mean, of course you get like giant monsters, but that, I mean, that's an RPG for you. But the environment itself, like you have this giant stuff that you can even make like just reality more interesting by scaling everything up. So that's why I think it's a nice environment, and you can be very creative with it as well. Okay, so this is, we have dot view, and we need damage on touch. And then yeah, and then we check here, so then we can say if dot shield blocks, then we do all this. Okay. Right, now we get instant kill here. Okay, nice. Okay, so yes, let's look at our to-do here. So we actually implemented this now. So physics collision groups. I also added, yeah, monster damage on touch, no shield block. There. Alright, so physics and the physics collision groups now makes it so that you don't push the monsters around. The monsters collide with the ground, and the player collides with the ground but they do it separately, so the player doesn't collide with the monsters, and the monsters doesn't collide with other monsters. So they don't push each other around. Great. What else? Yeah. So we did all this stuff as well. Let's see. Okay, so what are we gonna do now? I think I'll call it actually. So because yeah, I've been running for a bit here, so I need to actually. This is a good stopping point here. Yeah, because I can't really think of anything low hanging fruits that we can do right now. But yeah, that was really nice. We got a lot of things done. So I have to figure out what to do next time. I mean, there's a lot of things to do, but I need to come up with some ideas to test. Maybe more combat. Maybe introduce more like another monster type or something. I'm not sure. We'll see. So yeah, but yes, that's gonna be it for this time. So anyone who's joined here, thank you very much for watching, and thank you for all the chat messages, and yeah, have a nice day, and I'll see you next time. Bye bye.